Alright, so you have 11 of you. Alright, we're waiting on a couple more. Michael, just follow along with us, even though your computer's dead, okay? Is everybody on? These? Okay. Alright, nothing. So, we are going to talk about macromolecules today. Okay, let's break down this word first. Anybody know what the prefix macro means?
Small.
That's micro. So if micro is small, macro is big. Okay, and what about molecules? Does anybody know what a molecule is?
Like part of an atom?
Atoms make up molecules, very good. Okay, so a molecule is something where we have lots of elements that are strung together. Okay, and some of the macromolecules that Ms. Roche just talked about, okay, which ones did she say? Protein?
Fats, carbohydrates.
Yes, very good. Proteins, fats, carbohydrates. So we're going to talk about those three today. Those three are the building blocks of all life, okay, including the DNA, which again, she said we're not going to touch upon just yet, okay, but we're going to talk about those other three right now. All right, so let's look at these lovely pictures. Okay, so here we have a molecule. This is glucose. Does anybody know what glucose is? Sugar. Very good. Glycerol. Have you guys ever heard of glycerol before?
Nope.
Okay, that would be a
Syrup?
fat.
Is it
That is a great question. I don't know. But glycerol is a type of fat, and then we have glycine. So if this is a carb, this is a fat. What is glycine? Protein. Very good. Okay, so one, what do you notice about some of the differences about this? Can I help you?
Oh, sorry.
Oh, okay. Bye. Have a nice day. Thank you. Okay, so macromolecules of life are made from repeating smaller monomers. Monomers are just one of them, right? Units such as glucose, glycerol, and glycine. So highlight some of the elements the macromolecules have in common. Okay, you can do that on your computers right now, guys. So, what do we notice here that they have in common? Something very basic.
The letters.
With the letters, who said the letters? Okay, yes, B, very good. Okay, does anybody know what that C might stand for? Carbon, very good. What about O? Very good. What about H? Hydrogen, very good. So we have, what about N over here? Nitrogen, very good. Okay, so here we have a lot of commonalities. Okay, there are a lot of differences, which make them different substances, obviously, but there are a lot of commonalities. So take a second and highlight the elements that the macromolecules have in common. What? Oh, you're writing? Yeah, so here, one of you guys did that correctly. There are some of the elements that we all have, or that all of these macromolecules have, are our carbon, our hydrogens, and our oxygens. Very good. These are the building blocks to our macromolecules. Okay, but what do you notice about these carbon, hydrogens, and oxygens? Are they made in the same manner? Like, do they look the same? No, not really, right? So here it tells you that carbon, hydrogen, oxygen, they can be reused in different ways to make different things, okay? I'll get it. You guys were correct, okay? You guys were correct. You said carbon, hydrogen, oxygen, okay? That is what the building blocks are, okay? And some of you, we already talked about this. There is a nitrogen. All proteins have a nitrogen and two hydrogens on the end. That's what makes it indicative of an amino acid, which are the building blocks to a protein. All right, good job, guys. Next. All right, so what is one way carbohydrates, lipids, and proteins are different? Okay, take a second. Think about how they're different, guys. We just talked about it. They have carbon, oxygen, and hydrogen, okay, but how are they different? Do they all look the same? Are they in the same shape? Like, do they have all of the same elements, the same number of carbons? number of hydrogens? What do you think? Really good, guys. They're different shapes and made in different ways with different amounts of molecules. Very good. Different shapes, different amounts. So basically you guys got it. Okay, their shape and the number of elements dictate exactly what their function is and what they're categorized as. Okay, so the way that you have the carbon, even if you have a straight line of carbon, if you have 3 carbons strung together versus 4 carbons, it's a completely different molecule. If you have 4 instead of 5, 5 instead of 1,000 carbons, it's a completely different molecule. So every carbon, every hydrogen, every oxygen, it matters. Okay, and what function it has and what part of your body is going to get broken down and put, to work, that depends on how many carbons you guys have, or they have rather. Good job. All right, so, okay, now, whoops. Oh, it's fine. All right, so read this. During chemical reactions, the bonds in molecules are continually broken and reformed. When the bonds are broken, energy is released. So a bond would be something like that's right here. You see that line? Okay, these lines, that signifies a bond. And what a bond is when another element is tied or it's next to another element. Okay, that's a bond. So when you break these bonds, boom, 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 okay, energy is released. Okay? When bonds are formed, energy is absorbed. So all of these molecules, even though you can break them down, at one point you can sort of put the bonds back together. But in order to put these bonds back together, you need energy. Okay, so you break it. It's like, you guys ever have a glow stick before? When you crack it. Okay, when you crack it, what happens? It lights up. Okay, that's a reaction. So think about when you break these bonds, you crack that glow stick, and that releases that energy. Okay, in order to put it back together, you have to add energy. Okay, so during a chemical change, the process can be used as a source of energy. A general rule for processes such as respiration, okay, our breathing, our cellular respiration, is the more carbon atoms there are in a molecule, the more energy the molecule can provide to the organism. So, looking at these guys right here, how many carbon atoms, count up, how many carbon atoms does glucose have? How many carbon atoms does glycerol have? How many carbon atoms does glycine have? Take a second and please do that. Or, do you guys want to do it together? Doesn't matter? All right, take a second. Great job. I'm so proud of you. Very good. Everyone's getting the 3. Wait, 1. Yep, that has you're right. This is correct. Okay, so even though it's kind of hard to see, okay, they're all labeled for you. Sometime in the future you may see this structure, you may see glucose, and it might not have all of the letters. But in this case, it does have all of the letters. So right here we have 1, 2, 3, 4, 5, 6. Okay, this has 6. Okay, this one has 1, 2, 3, and here we have 1, 2. Actually, the main part of this protein, there's 1. This is something called a functional group, but we won't talk about that right now. So, which one do you think, I need my clicker. Which one do you think has the most energy? Do you think your carbs, your lipids, or your proteins? In this sense, if the more carbons you have, the more energy you have, the more energy you get, which one of these has the, yes, Lemon?
Carbohydrates.
Carbohydrates, very good. Okay, I don't know how many of you play sports or how many of you work out, or how many of you, watch what you eat and lift, okay, but if you do, carbs are the most important part of your diet, okay? A lot of people who wanna lose weight, they cut out their carbs. And yes, you do lose weight, however, you have nothing to build the muscle, you have nothing to sustain your energy. So, carbs are very important, and not all carbs are bad, okay? I want you guys to understand that not all carbs are bad, okay? There are carbs in vegetables. Okay, does anybody know what vegetable is very high in carbohydrates? Sí, señor. Potatoes, very good. Potatoes, rice, things that are starchy and sticky, okay, all of those are very high in carbohydrates. You get a lot of energy from those. Okay, yes, are they higher in calories than a piece of celery? Okay, but potatoes are way better than celery, we know this. Okay, then we have our glycerol, which we have 3 carbons, and last but not least, we have our glycine, which just has our 1. Really good job, guys. So which one do you think our lions are gonna go for? Yes, right? All right, so now let's add another step. Let's talk about our elephant's diet in carbohydrates. Okay, this is called sucrose. Does anybody know what sucrose is? It's just like glucose, but it's sucrose. You said it before. Sugar, very good. It's just a different type of sugar. If you look real quick, look at this glucose molecule. There's one, right? There's just one part to it. Now look at sucrose. Okay, how many parts to that does sucrose have? 2, really good. Okay, so sucrose, even though this is one molecule of sucrose, it has 2 parts to it. It has a glucose and a fructose that are bound together by that little oxygen, and that's what makes it sucrose. So this is table sugar. Okay, anytime you use like white refined sugar, put in your coffee or tea or just eat handfuls of sugar, whatever, this is what it looks like. Okay, honey looks very similar. I forget which one it's bound to. It's fructose and galactose, I don't know, something else. But anyway, honey looks something similar like this. So, there are many chemical reactions that occur in your body right now. So as you eat food, as you drink anything, molecules are broken down by something called an enzyme. Have you guys ever heard of the word enzyme before?
Yeah.
Do you know what an enzyme does? It does break things down, but it does so quicker. Enzymes speed up reactions. So, if you were to eat a delicious hamburger, okay, which is like one of my favorite foods. If you were to eat a hamburger and you weren't to have any enzymes in your mouth, in your stomach, in your body, it would take days, maybe weeks, to break it down, okay, in your stomach. Okay, the second you take a bite of something, you have enzymes in your saliva, and what it does is it starts to break down that food, and it starts to break them down into molecules that look like this, and it speeds everything up. Okay, so when you eat a burger at 7 a.m., whatever, or eggs at 7 a.m., you're hungry again in a couple of hours. That's because this is already broken down, and it's moved through your system, and it's getting all the energy out of it that, it can. So, anyway, enzymes, they speed up reactions, and a chemical reaction takes place. The bonds between elements are broken and reformed. Again, break the bonds, release energy, form the bond. You need energy. Energy can be given off or taken when the reaction occurs. Left side is the before arrow. These are called reactants because this is what is reacting in the chemical equation. And the left side before the reaction, what goes in, they're called reactants. While the right side, which is right here, what do you think these are called? Starts with a P. Products. But why? Because it's being what is produced, right? Being produced. Okay, so these are our reactants, these are our products. The number of elements that go into the reaction should be the same number of elements that you started with, okay, versus what you end with. It's just simply rearranged into something else, okay? So chemical reactions are usually reversible, okay? Again, if I break this bond, it's gonna release energy. Now if I wanna put it back together, I have to add energy, All right, so put a red dot near the reactant and a blue dot near the product. We sort of went over this, but just take a second and do it. Okay, am I doing that or are you doing that? You're doing that. Okay, perfect. Good. So these are our reactants. These are our products. Very good. Next. So again, every single time that you have any chemical reaction, whether you're making water, you're making carbon dioxide, you're making anything, you're making table sugar, you are going to see that this arrow always points to the product. It always points to whatever is being made. So this arrow means something called yield. Okay, have you guys ever heard of the word yield before? Not so much as in driving. Not like yield, yes.
The foods class has heard about the word yield.
Okay, so do you remember what it means?
I think what it means is like, kind of maybe like the average or something.
That's a good guess. Yes, it's a very good guess. So in chemistry and biology, what yield means is to be transformed. Okay, it means to be transformed. So these reactants are going to be transformed into these products. Okay, so if I were to switch this arrow this way, what would this now become? The reactants, very good. If the arrow was switched and is pointing this way, these would be my reactants, these would be my products. Very good. All right, so now this is the same slide. What would you call the body process that is occurring? So breaking down table sugar into small sugars. What do you think that this is called? What? Very good, very good. Yes, beautiful. Okay, this is digestion. Every time that you eat something, drink something, this process of digestion is going on. Okay, I don't know if you guys have ever been on a diet or, like when you're sick, you don't really eat a lot. What do you feel like when you don't have food? Tired, slow, unhappy. Oh God, I get hangry, okay? You feel lethargic, you feel like you have brain fog. That's because your body is disrupted, not respiration. It's not photosynthesis either, but yes, it is digestion. So food is very important. Food is insanely important for your everyday function, okay? All of you guys before said that you didn't eat breakfast. That's not the greatest. I know that, listen, I'm totally guilty of it. I never eat breakfast, but I do have an insane amount of coffee, so it's at least something. Okay, so at least there's a little bit of sugar in there. You should have something, a granola bar, an egg, maybe a Nutri-Grain bar, maybe some coffee, anything. Just so your brain and your body can get jump started. Okay, because if you just start your day out with nothing, your body is, sort of lagging. It's lacking what it needs in order to function. And then you fall asleep in the first period, and then the whole day is, you wanting to eat your lunch. Good job. All right, so everybody has digestion except the one funny guy who put photosynthesis. All right, starch. This is what starch looks like. Okay, Jose said that potatoes have a lot of starch. Okay, starch is a complex carbohydrate found in plants which contains approximately 200 glucose molecules. Predict the function of starch. Doesn't have to be super specific. Think generally. What do you think the function of starch is? Excuse me. Okay, that's a good one. Just write it down for me, Vic. Remember, enzymes speed up a reaction. we haven't talked about building body parts yet, so, I don't know about that one. But anyway, most of you said energy. Yes, very good. Okay, starch are energy-rich molecules. Again, anytime that you have, you eat rice, you eat potatoes. Has anyone had juca before? Who? Juca? Yeah, it's spelled J-U-C-A. It's like a potato, but it doesn't look like a potato. What is that, Cuban? Cuban? Yeah, they have, maybe I'll bring them in one day. Juca fries are so good. They're so good. It's called YUCA. YUCA.
I've never heard of it.
But anyway, that is another type of starch. Okay, very energy rich. Anytime you guys have had any family or mothers or fathers, brothers, sisters that are in the military, they always give you a starch, they give you a protein, and they usually give you a veggie. Okay, they give you a starch, which is usually rice, sometimes potatoes. My dad was in the Army. His job was to peel potatoes. He said it was the most miserable time in his life. But he peeled potatoes, you always get a starch, and then you get like a lean protein, something like a chicken or a fish, just so you have the most amount of energy. All right, so we said energy. Okay, so now let's look at some proteins. Okay, can you guys think of any proteins that we're not talking about in elephant's diet? What's a protein? Yes,
Food.
Yeah, name a food. Chicken. What else? Ground beef. Beef in general. What about fish? Okay, salmon's my jam. Okay, that is a protein. You guys, if you're trying to gain muscle, you hear people saying that they're going to eat a lean protein. A lean protein is something that doesn't have a lot of fat in it. Like, for example, ground beef versus like a filet mignon. Okay, ground beef has a lot of fat in it, filet mignon does not. Okay, if you look at the cuts of steaks, okay, versus like a ribeye versus a fillet, okay, there's the amount of fat content in there. So, now, let's look at the elephant's diet and lion's diet in the proteins. Here, you see something called a dipeptide. What does the prefix di mean? No, it does not mean di. What about mono, di, tri?
5.
Si, senor.
2.
2, very good. Okay, there's one peptide here, there's another peptide here that are bound together. Okay, so here you have a dipeptide plus H2O. What's H2O? Water. Okay, what does this side mean again? Starts with a Y? Yield, very good. So, here we have our dipeptide plus water, and then what happens? We're breaking them down into something called an amino acid. Okay, an amino acid, these are the building blocks to proteins. Now, what is this side of the reaction called? What are these called? Reactants, and these are called? Very good. Very good. So what process is occurring in this figure? We already said it. Digestion. Very, very good job. All right. This might take you a second. So, there are 20 different amino acids. So here, you can see, this is amino acid number 1. This is amino acid number 2. This is amino acid number 3. First and foremost, what do you notice about the differences between them? The shapes and the chains, okay? All of these, remember I said that carbon, that the shapes, you might not see the carbons. These little triangles, the tops and the bottoms, these are all carbons. Okay, this only has, it's one carbon with the functional groups on each side. This one has 1, 2, 3 carbons. This one has 1, 2, 3, 4, 5, 6 carbons. Okay, so again, they look differently, they do different things. It's sort of like, do you know your DNA, the way that it is set up? That makes you who you are, right? It gives you brown eyes, blonde hair, red hair, freckles, gives you a widow's peak, no widow's peak, all of that. You ever heard of a widow's peak before?
Yeah.
Yeah, I have a widow's peak, a little bit.
They're terrible.
A little bit. What are you gonna do? Oh, you have one too. Yeah, it's the same. We're the
Wow.
same.
Wow.
We're the same. We're the same. Anyway, based on the information above about how proteins are made and are different, use the 3 amino acids above to create 2 proteins with 4 amino acids. So again, there are about 20 different amino acids found in the body. There are thousands of different proteins being used by your cells. So how proteins differ in their types and sequence of number of amino acids allows for thousands of different proteins to be found and made in your body. So when you consume a protein, it's broken down into these individual amino acids, and then these amino acids are now used to make different proteins. So again, you are going to make your own protein using these 3 amino acids. So take a second, okay? This is your example. Amino acid number 1, amino acid number 2, amino acid number 3, and another amino acid number 1. Don't recreate this, but make your own protein, okay? Using these 3 amino acids, all you have to do is sort of put them in another sequence or order, thank you, and then you'll make a new protein. Whoops. Stop deleting your responses. Perfect. This person has amino acid number 3, amino acid number 1, amino acid number 2, and amino acid number 1. Is that the same as this one in yellow?
No.
No. Does it have the same amino acids though, like the same building blocks? Yes, they're not in the same order though, which gives it a completely different function, okay? There are amino acids that do everything. That make proteins that literally do everything in our body. We have proteins that start breaking down our food. We have proteins that take down our sugar or glucose level. We have proteins that bring our glucose level up. You name it, there's a protein that does its job, okay? Let's see another one. Here we have amino acid 2, 3, 1, 2, very good. Okay, we have amino acid 2, 2, 3, 2, that's very good. And last but not least, we have 3, 1, 2, 1. Okay, perfect. I have a couple more slides, guys, and then we are done. All right, now, last but not least, we have lipids and fats. Can anyone think of anything that is a fat? Si, senor. Avocados, yes, they're the best fats. Me too, I live for avocado, anything. Avocado toast, guacamole, I live for avocados. Okay, yes, they are good fats, okay? And can anyone think of anything that's a bad fat? Coconut oil is actually, it's a good fat, but it's very high in calories. What else is a bad fat? Yeah, like a processed something, like what? Oils are fats, yes. Depending on what type of oil it is, it's either better for you or worse for you. So for example, like canola oil or vegetable oil, not the greatest for you. Things like avocado oil, coconut oil are much better for you because you get nutrients out of them. Whereas the other ones, they're really just creating trans fats and other things that are not good for you. All right, so looking at these guys here, I have a monoglyceride. What does mono mean? One, very good. Plus a fatty acid. What does this word mean again? Yield, very good. And then I have a diglyceride, which means two. Okay, so what do you notice the monoglyceride and diglyceride compared to our proteins and compared to our carbohydrates? What do they look like? Well, the glucose had a ring, right? Yeah. The proteins had different shapes. Some were straight, some weren't as straight. But what do you notice here? There is a large chain. Remember, these are all carbons. So we were counting the carbons before. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 carbons long. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 carbons long. Okay, so fatty acids, okay, fats and lipids, they have very long chains of carbons. Okay, that's what gives them their hydrophobic state. Okay, that's what gives them their ability to resist our water. Okay, what happens when you make oil and vinegar like dressing? No, does not blow up. What? They don't mix. Okay, you will have the oil sitting on top of the vinegar. That's because of these carbons right here, that you have the carbon, nope, you have the oil sitting on top. They do not like to mix. They have their own, they like to keep their own shape. Okay, even if you shake it up, you can still see the oil granules within the dressing, and then it'll eventually settle and it will dissipate or not mix. Okay, so place a red dot near the reactants and a blue dot near the products. Okay, remember our yield always points to the products, so take a second and do that right quick. Okay, these are our reactants, very good. This is our product. That's good job, yeah. Very good. All right, reactants, products, you guys got this. You guys got the yield, very good. Now, which molecule will give more energy? Diglyceride or glucose? So if you remember, this is glucose right here. Okay, sorry, it's kind of being taken over by our little code right here. But this is our glucose molecule. This is our diglyceride molecule. Which one do you think is going to give more energy? Take a second. Remember, what gives energy? And what's the building block of that? So, take a second. Answer the question. All right. So most of you said diglyceride. Let's see. No. Very good. Oh, wait, I skipped it. All of you that said diglyceride, you are correct. Can anybody tell me why diglyceride is going to give us more energy? They have way more carbons. Remember, carbons are the backbone. They're our basis for energy. So if you eat a fat that has a long chain of carbon, okay, you're going to get the maximum amount of energy. Remember, glucose only has 6 carbons. So this one, I think I counted 17 or 18, something like that. So our diglyceride will give us the most amount of energy. Very good. Okay, I already asked this question. Why does diglyceride give more energy? Carlos said because it has more carbons. That is correct and very good.
What? Just call me Carlos.
Oh, sorry. Jose. No. I'm sorry. How would you describe digestion? Use the model of the protein below. Use the words protein, dipeptide, monomers, building blocks, and amino acids in your answer. So, how would you describe digestion? Okay, use the model of the protein below. Okay, so you're going to describe what is happening right now in the elephant's diet and lion's diet. Okay, so you're going to describe digestion in your own words. However, please use the words protein, dipeptide, monomer, again, monomer, okay, are the building blocks, and amino acids in your answer.